we will be discussing the problem in Pytle's book at page 136. Number 3.48. Determine the resultant of the line load acting on the beam ABC. First, let's identify the given and the unknowns. Then, we should change the distributed load into individual forces. Let's start with the distributed load at AB. We first start into a single force with a magnitude that is equal to the area of the distributed load, AB. Then we locate that single force 1/3 away from the side with a 90-degree angle, which is 4 feet from point A. Now, let's transform the distributed load at BC. In order to change it, we first separate it into two different parts. The first part is a rectangle having a side at the x-axis of 8 feet, and the side at the y-axis of 1,200 pound/foot. While the second part is a right triangle with a longer leg of 8 pound/foot, while the shorter leg of 500 pound/foot. We now start transforming the distributed load. We begin with the rectangular one. We first transformed it into a single load by getting the area of the rectangular distributed load. Then, we position the force at the middle of the length of the distributed load. Then, let's do the triangular part. We do the same procedure that we have done at the distributed load at AB. Now that we are able to transform the distributed load into 3 individual forces, now let's find the resultant force of the system. We must add all up the forces to solve for the resultant force. We then find the point of application of the resultant force. First, we assume the moment center in this video. Point A is the moment center used. Point B and C can also be used as a moment center, and they should yield the same answer. Next, we are to establish the moment equation in respect with the desired point to solve for the resultant moment. Now we know the resultant moment and the resultant force. We can now locate the position of the resultant force. We just equate the product of the resultant force and x, where x is the distance of the resultant force from force A, and the resultant moment. After solving this equation, we could solve the distance of x, which is 8.75 feet.